Alright, in this continuation of part 10.50, we've already considered the perfectly inelastic collision, which actually turned out not to be too bad. And from the first part, okay, we found that regardless of the type of the collision, in order for the block, the big M block, not to fall off, V prime must be equal to the square root of 5g times r, the radius. And so in this one, we're going to consider an elastic collision. And so that one looks a little different and actually turns out to be just a little bit harder, not necessarily because the physics is any harder, but because the math is a bit more involved, and I want to sort of work it all out so that we can see what it looks like. And so if we try to visualize what's going on here, again, sort of before, we have the small mass with some speed Vm, and the big mass is at rest. Oops, big mass is at rest. And then after, well, afterwards, it turns out that the little mass is actually going to be moving in that direction, and I'm going to call this Vm final, V little m final. And the big mass is going to be moving to the right with a speed v prime, right? And that's and what we're trying to figure out is, what does Vm have to be in order that v prime satisfies our condition that the mass goes all the way around the loop. Okay, and so in this problem, not only is delta p equal to 0, but also the change in the kinetic energy is also 0. We're going to have to use both of those facts. Alright, so let's start with momentum. P initial is equal to P final. And so I have little m times Vm is equal to, well, the final momentum, I don't know what Vm final is going to be. Right? So I'm not going to explicitly put it in there as negative. So I'm just going to call it mVm final plus big M V prime. Now, the sign of Vm final will come out in the end if we should want it. All right? So if it's moving to the left, it'll be negative. All right? So that's momentum conservation. And the kinetic energy initial must be the kinetic energy final. So if I look at the various terms here, I get 1/2 m Vm squared must be equal to, and there are two terms in the final kinetic energy. There's 1/2 little m V little m final squared plus 1/2 big M V prime squared. Now at this point, we are essentially done with the physics, and so now this part is just really an exercise in algebra, which I know everyone loves, but nonetheless, we're going to work through it. We're going to try to develop our sophistication a smidge. Okay. So the first thing that I'm going to do is, I know that I don't really want V prime. Well, I don't care about the final velocity of the smaller mass. I don't care about that. So what I'm going to do is I'm going to solve this expression for it. And so Vm final will bring this to the other side, divide by little m. I get Vm minus big M over little m, V prime. And then I'm going to plug this directly into the kinetic energy expression. So I get 1/2 little m Vm squared is equal to 1/2 little m, and I'm going to plug that in here, Vm minus big M over little m, V prime, square that whole thing, plus 1/2 big M V prime squared. Alright, now I have to expand this out, so this is 1/2 little m, and so I'm going to expand this thing, and so I get a Vm squared term. I get minus 2 big M over little m, V prime, Vm plus I get an m over little m squared times v prime squared, and then this term comes along plus 1/2 big M v prime squared. Okay. Now I'm going to expand this through, but I do want to point out that there's a term in here, this term here, when I expand it out, that's going to cancel directly with that term. Okay. So I'm going to distribute that through, but I'm going to make that that simplification explicit. So 0 is equal to this term, so I get a 1/2 times little m, and I get a minus 2, so I get a minus big M v prime vm. I distribute my 1/2 m, so I get a plus 1/2 big M squared over little m v prime squared, plus, and then this term hangs out, 1/2 big M v prime squared. Okay, now it's done in the text, but I'm going to sort of explicitly do it here. I'm going to pull out a v prime square, a v prime here. Okay, so I get a v prime comes outside of everything, so I'm going to pull it out of everything. I get minus big M times Vm. I get a plus 1/2 big M squared over little m. I get a v prime that hangs out there, and then I get 1/2 big M v prime. Now, when you read this expression, this tells you that there are two solutions. There are two ways to solve this. The first one is that v prime could be 0. Right. Now that turns out not to be an interesting solution, because that's when the little block goes right through. So that satisfies momentum and energy conservation. It's not going to end up satisfying our requirement that the big M go around the loop, because if it misses, if the little block misses the big block, well then the big block's not going to go around the loop. Okay, so we don't want that solution. The solution that we want is that 0 is the stuff in the parentheses, minus big M Vm plus 1/2 big M squared over little m v prime plus 1/2 big M v prime. That's the one that we want. Okay, and so I can see that I have a mass big M that shows up in every term. All right, and so I get 0 is equal to minus Vm plus, and then I'm going to combine. I want my v prime over 2 to come out, and then I end up with big M over little m plus 1. Or what I can do is I can actually solve for Vm. Vm is equal to v prime over 2, big M over little m plus 1. And now I'm going to substitute in my result from the very, very, very beginning that said that v prime had to be the square root of 5gr. And so I can go ahead and just plug that right in. I get Vm is equal to looks like maybe I have, sorry, I'm checking my result here. I want to make sure I have this factor of 2 sorted out here. It's possible that looks like that I missed a factor of 2 somewhere. Vm, let's get the v prime, plug it in. Well, maybe it's going to work itself out. Let's see. See if it works itself out. I'm not sure that it's going to, but let's just see. So I'm going to plug this thing in here. So I get square root of 5gr over 2 times big M over little m plus 1. Okay. And So somehow it looks like, I'm checking my notes here. Sorry, I'm trying to find it. What did I do wrong here? So I have a 2, VM over here, plugged in V prime. Get that thing. Okay, I'm going to pause for just a minute and I'm going to check through this and see where I went wrong.